Hello everyone, my name is Arun and welcome to my channel. In this video and in the next few subsequent videos, I'll be talking to you guys about a program to do the matrix multiplication. Essentially, we'll be entering a matrix, giving two input matrices to this program, and the C program will just take those matrices and do some calculations and give us the matrix multiplication, the product of these two matrices. Okay, and for that I have this fairly long program over here which will take me a few videos to explain. So in this first video I'll be explaining the initialization of 2D arrays and also the concept of macros. Okay, I'll walk these through as we go along. Okay, here's actually the program starts. I include this header file as usual, and I define two constants over here. These two constants look like preprocessors, okay, with a hash and with a hash symbol in the front. Okay, so these are actually called as macros. Macros are nothing. Macros are in simple terms, if you want to put it, these are like these are actually constants, and you create macros by using the preprocessor directives. Simple as that. Okay, so to define a macro, you put a hash and then you write the keyword define, and then you write the macro name and then the value the macro should hold. And once you define that, as long as this till the program gets terminated, this value max row will have this value 10. Okay, if you want to change the value, you cannot change the value. You just have to go inside the code and modify it manually. Until then, you cannot change the value. Okay, one macro that we came across in one of our previous tutorials is that this m_pi, which actually stood for the pi constant. Okay, and this is actually present in this one is present in math_h library. Okay, so I define a macros for rows and columns, and usual notation is that when instead of using the unlike variables, it's recommended to write macros in full case, like in uppercase, all of them in complete uppercase. The reason is because whenever you write a program and when you want to compare between when you want to differentiate between a macro and a variable, this full uppercasing will give you a good distinction. So do not write variables with complete uppercasing. So only use that for macros. This is actually it's not a hard and fast rule, but if you follow it, it's a bit convenient. That's it. So I'm creating three iterating variables over here for loops that will come across in the future, and define four variables R1, R2, C1, and C2. These variables correspond to the number of rows and number of columns in matrix 1 and 2. So R1 and R2 define the number of rows and columns in matrix 1, R1 and C1, and R2 and C2 define the number of rows and columns in matrix C2 or matrix 2. Okay, and here what I'm doing is I'm defining a 2D defining a 2D array which for our matrix. Now, usually in the last program we saw 1D array which has just plainly arrays which has undefined, and you define them by putting a data type, a name, and within square brackets the maximum size for the maximum size or the maximum number of entries. For 2D array, it's a bit different, slightly different. Although it's an extension of that, it's slightly different. What you do is that you just put the number of you imagine the matrix to be some 2D array to be like a matrix. So what do you need to define a size of a matrix? You define the number of rows and define the number of columns. Perfect. And that's how you do. You put the variable name, and within first brackets you specify the number of rows, and second bracket specify the number of columns. And here's a catch. You cannot define a matrix size. With variables. You have to either use them with plain numbers or by constants. The reason is because if you define a matrix size using a variable, okay, the logical reasoning is that the variable's value can change over the course of the program and can be modified easily. So if you define a matrix with sizes corresponding to some variable value, after some time the value gets changed, then you cannot go and set the size again. So that's as a fail-safe mechanism. Arrays do not allow you to set its sizes using variables. You have to use either plain numbers or constants. That's why even while compilation you'll get an error if you do it improperly. So this will not throw an error. So instead of this macros, if I use numbers, if this one throw any error, this is also a legit way to go about with it. But the moment I use a variable, I'll get so many warnings. If I scroll up, I get the first error. It says variable sized object may not be initialized. I hope you can read this properly. It just says that I cannot use variables to define the data type size. And I comment this out, and instead I comment this out, and then instead I put the variable, macros. It will work perfectly fine. And then what I'm doing over here is I'm not only defining the matrix, but I'm also setting up what the matrix values are using this format. You can ask me, can I initialize the matrix after I define this in a few lines afterwards? No. If you want to do that, it's actually have to be the hard way around, okay, which I'll tell you in a minute. So there are like 3 ways to initialize matrices. First way is actually the standard intuitive method, wherein you put the data type, you put the sizes, and within curly brackets you define the entries. So the syntax is, you put a curly bracket and you put a curly bracket and put a semicolon at the end to indicate all the things that are contained by this matrix. And what you do over here, you put the entries of the matrix in the first row within curly brackets, put a comma, put the within other curly brackets, enter the next the entries in the second row, and entries in the third row is in curly brackets, comma, entries in the fourth row, and you proceed further, so on and so forth. And for the and since this is actually a 4x4 matrix, after this entry I don't need a comma because there aren't any more rows, so I can leave it as it is. So these 4 entries will be the first 4 entries in these 4 values will be the 4 entries in matrix 1, row 1. These will be the entries in row 2, these 4 will be the entries in row 3, and these 4 will be the entries in row 4. And the columns match accordingly. So this is actually if you look at it, it takes a little more time to write, but it's very intuitive because if you have a 2x2 matrix, and this is very easy to cross check because of this structure. You can write it as any way you want, but I just written in this manner with tabs and spaces, and also that it's easy to visualize. It's actually a programming convenience thing. Okay, you can write it any way you want. And method 2, what I do is, it's a slightly smarter method, but it comes at a visibility cost. What I do over here is I just define the matrix and define the sizes, and then you put the values, and let's see automatically fill in the entries. So what will happen here is, since this matrix has 4 rows and 2 columns, and there are like 8 entries in it, first 2 entries will go to the first row, second 2 entries will go to the second row, and next 2 entries will go to the third row, and next 2 entries will go to the fourth row. So C will automatically fill it for you. This is actually a slightly smarter way, but thing is, in this method, first method gives you the advantage of cross verifying the numbers perfectly, because this is very intuitive. This one, if you just have to be cautious because you won't get that intuitive feel of the matrix. This is perfectly fine for 1D matrices, but but for multi 2D matrices, this is not a good way. And method 3 is actually an extension of method 1, and this is actually a partial initialization method. This is fairly straightforward. What you do is if you just enter some values of the matrix in each row and column, and you leave them as it is, the remaining values will be filled with 0. That's all about it. So in this configuration over here, the first 2 entries of row 1 will be filled with these values, the remaining 2 will be filled with zeros. Row 2 will be filled with these 4 values. Row 3 will be filled with 2, and the remaining 3 values will be filled with zeros. And in row 4, the 3 entries will be filled with 4, 9, and 11, and the last entry will be filled with 0. And if you do not want to initialize a matrix while you define the matrix, there are like 4 ways to initialize them. The first option is to read the data from files. For this is actually recommended for big matrices, and it uses loops. The second method is actually using loops, and let the user initialize the matrix by setting the values during runtime. This is actually preferred for small arrays. And then you can use loops to automate the initialization if suppose the data in the matrix has some kind of pattern in it. And then finally you have to manually set each and every value, which is actually too much work. For instance, if I had to initialize the first 4 values of this matrix, I have to manually write like this. This is actually cumbersome. Okay, We'll talk about these 4 initializations in the next video and in the future video. Alright, now I'll see you all in the next video, wherein I'll be talking about the remaining parts of this program and the remaining interesting concepts. Okay.